Section 7.3 Applications of the Normal Distribution. Lesson Objectives: Find and interpret the area under the normal curve. Find the value of a normal random variable. Lesson Objective number 1. There are 4 steps for finding the area under any normal curve. Number 1. Draw a normal curve and shade in the desired area. Number 2. Convert the values of the random variable x to z-scores using the z-score formula. Number 3. Draw a standard normal curve and shade in the desired area. Step number 4. Find the area under the standard normal curve by using table 5. This area is equal to the area under the normal curve drawn in step 1. Let's look at an example. So this is the distribution for heights of men and women in America. Men have a mean of 70 inches and a standard deviation of 2.8 inches. Women, the mean is less, 64 inches, and the standard deviation 2.5 inches. What is the probability that a randomly selected man has a height less than 65 inches? And that's the same thing as 5 feet 5 inches. Our first step is to draw a picture. Mu is 70. The random variable we're interested in is 65 inches, and we want less than. So that's area to the left. From the picture we can see that this is less than 0.5 because it is less than 70. Our next step is change our random variable to our z-score. So we're going to take x minus the mean divided by the standard deviation, and we end up with a z-score of a negative 1.79. Looking up a negative 1.79 in table 5 yields this probability, 0.0367. So the interpretation of this, if we randomly select 100 men, we'd expect about 4 of them to have a height less than 65 inches. Let's look at another example. What is the probability that a randomly selected woman has a height between 60 and 67 inches? Our first step is to draw a picture. And in this case we have 2 random variables, 60 and 67. Our mean is 64. So we want to find this area between 60 and 67. So our next step is we have to convert 60 and 67 into z-scores. So 60 minus 64 divided by 2.5 yields a z-score of negative 1.60. 67 minus 64 divided by 2.5 yields a z-score of 1.20. Now our next step is to look up the largest z, 1.20, in table 5. And write that probability down, 0.8849, and look up the area that corresponds to a z-score of 1.60, which yields 0.0548, and then we subtract these two, and our area is 0.8301. The next example involves Kings Island and Drop Tower. At 315 feet, Drop Tower is the world's largest gyro drop. Drop Tower spins riders on a 30-foot ring of 40 seats that encircles the drop tower to a staggering height of more than 26 stories, and then drops the guests in a 65-mile-per-hour free fall. So here's some pictures. Now, in order to ride Drop Tower, you have to have a height between 48 inches and 80 inches. What is the proportion of men that cannot ride this ride? First, draw a picture. We're talking about men, so that has a mean of 70. We want less than 48 and greater than 80 inches. So we convert these to z-scores. So the z-score of 48 inches would be a negative 7.86, which we would have to use our default value 0.0001. If we convert 80 inches into a z-score, we end up with 3.57. So again, we have to use our default, this time 0.9999, and we're wanting the area to the right, so we have to do 1 minus, which yields 0.0001. So the proportion of men who cannot ride this ride would be less than 48 inches or greater than 80 inches. So therefore, we would add these two probabilities up, and we end up with a proportion of 0.0002. The Beanstalk Club, a social organization for tall people, has a requirement that women must be at least 70 inches tall. What is the percentage of women meet that requirement? Now, at least 70 inches means 70 or more. So if we look at the picture, the mean of women is 64. Our random variable is 70. We want 70 or more. So we need to convert our random variable 70 to a z-score. So we're going to take x minus the mean divided by the standard deviation, and we end up with a z-score of 2.40. Looking up 2.40 in table 5 yields a probability or an area of 0.9918, and since we want the area to the right, we have to do 1 minus that area, which yields 0.0012. If we randomly selected 10,000 women, we would expect about 12 of them to have a height tall enough to join the Beanstalk Club. Lesson objective number 2. The procedure for finding the value of a random variable corresponding to a specified proportion, probability, or percentile. First, you draw a picture and you shade in the area corresponding to that proportion, probability, or percentile. Use table 5 to find the z-score that corresponds to that area. And step number 3, obtain the normal value from the formula x equals mu plus z times sigma. Now this formula here is derived from the z-score. So if you take the z-score and solve for x, this is the formula that you get. Some cautions to keep in mind. Don't confuse z-scores and area. Z-scores are distances along the horizontal scale, but the areas are regions under the normal curve. Table 5 lists z-scores in the left column and across the top row, but the areas are found in the body of the table. Choose the correct left or right side of the graph. A z-score must be negative whenever it is to the left half of the normal distribution. Areas or probabilities are positive or zero values, but they are never negative. Let's look at an example. What is the height of a man whose percentile height is at the 85th percentile? In this problem here, we're given a percentile. This relates to area. So if we look at the picture, we see that the area here, we want to find what height where 85% is less than or equal to that value. Look in table 5 to the closest thing to this value, 0.8500. Looking this up, we end up with a z-score of a positive 1.04, and this agrees with our picture that the z had to be a positive number. Now using 1.04 for our z, and again mu is 70 and sigma is 2.8, we multiply these two and add it to 70, yields 72.9. So the interpretation of this would be about 85% of heights of men are 72.9 inches or less, and about 15% of the heights of men are 72.9 inches or more. Using the data from the previous example to determine what height separates the shortest 99% from the tallest 1% for American men. If we draw a picture, what we're wanting to find is the value, the height, where the area to the left is 99% or 0.9900. So we're going to look for table 5 to the closest thing to this value. Okay, Looking it up in Table 5, we see our z-score 2.34. We multiply that by our standard deviation and add 70. We end up with 76.552, which is about 76.6 inches. So the interpretation, about 99% of heights of men are 76.6 inches or less, and the tallest 1% of heights of American men are 76.6 inches or more. Here's the reading and suggested problems. Thanks for watching.